So this is going to be a rundown of like shapes and naming shapes, and for Chem 115 this is going to be essential skills quiz number 8, and actually a large chunk, or I think it's 50%, maybe 50% of the next exam, which is going to be like naming and doing the Lewis dot structure and coming up with this. So I'm just going to kind of run down what all this looks like and upload it for reference later on. So yeah, I just added color because it's kind of boring. So what you're going to have is, for this first column, is the number of atoms attached to a central atom. So it's not all of the atoms combined, it's what's attached to a central. So for example, take methane, CH4. Carbon is going to be your central atom, and then you have 4 hydrogens. So that's 4 atoms attached to your central electron. So these are the number of atoms attached to your central atom, not electron, central atom. And then this is the number of lone pairs of electrons. And so for some it's 0 and 1 or 2, but the thing is about lone pairs of electrons is that they aren't, when you're drawing them, which you don't really have to, we're not going to have to draw them, but this is good to keep in mind about, like, because you're going to need to eventually, and you're going to need to memorize this, especially when it comes to hypervalency and what that might look like. But a good way, because it also will help you to memorize what you're going to be, like what the names are going to be. And then, so that's kind of here. And this happens when you have lone pairs, is when you go through bonding and you have leftover electrons, and you're going to put them on your central atom. So take, I don't know, there was one that I went over today, and so just say you have a central and you have one bond, and then there's 2 atoms, and you fill out 6 electrons per thing, and then you have 2 left over. Okay, well, you're going to put 2 here. So then you have 2 electrons and your 1 extra pair of electrons, and a pair is 2 electrons. Okay, or equal to 1 bond. So 2 electrons equal to 1 bond, and then a double bond is 4 electrons. Just basic. And then these are like naming. And so we'll kind of go over this. This is our naming column. We'll kind of go over it. I have a drawing of each. I have if it's a 3D or 2D, which really helps with like recognizing what it would be, and then the degrees. And then these are also color coded based off of based off the angles. So if you have a total of 2, then your degree is going to be 180. And if you have a total of 3, then it's going to be 120. And then if you have a total of 4, it's going to be 109.5 degrees. And that sounds a little bit weird, but that's kind of what you're going to have to remember. It's just an odd number. Okay, so let's just kind of go over it individually. 2 electrons, 0, it's going to be linear, 2-dimensional. 2, 1, bent. And this electron here is pushing it down, so it's not a part of the electron configuration, but it's 2-dimensional and it's pushing these down. But then if you have 2 extras here, then it's going to push you down even more. So these are 2 bents. So this bent is going to be 120, and this bent is going to be 109.5, and you have to write that out when you're doing it, or when you have to write it out on the test, okay? 3, 0, trigonal planar, because there's no force like an electron pushing it down. So it's going to be on one plane. 2D, it's going to be on your x and y axis, but this one is on the XYZ axis. And 3 and 1, so it's going to be the same thing, but you're having this force push these electrons away, or these atoms away from the electron pair. Now for 4, the tetrahedral. So like this is a methane. This would be what methane looks like, where you have your central atom, carbon, and then these are your 4 hydrogens. And tetrahedral, again, there's 4, so it's going to be 109.5, and it's 3-dimensional, and it's going to be on the XYZ plane. So let's just want to wrap it up. I don't want it to be too long, but that's just the rundown of what this chart is and how you would use it.